So first, a little bit of a disclaimer. This talk was written for a Pythology, which are fantastic events. You should all sign up and buy tickets now. Written for a Pythology that I think was in February or something like that. So there's a couple things that are out of date. I will make note of those. And other than that, hold on to your hat seats. All right. So the original title of this talk was Connecting the Physical World to the Digital World. And I thought that was a really boring title, so I added a little bit to it, or how we automated the speakeasy with IoT and Python. And then about 10 minutes before I started to give the talk, I realized there was actually a better name for it. So I'd like to take this opportunity to rename this to Rube Goldberg Goes to the Speakeasy, How We Over-Engineered a Minor Inconvenience. So my name's Cameron Dershem. You can find all my contact info at pinkhatbeard.com. That's pinkhatbeard.com. There's a gentleman in the room that asked me to plug him today, which is Pink Hat Beard's a consulting company, and right now I'm consulting for that gentleman right over there, Tyler at trainerpush.com. You owe me now. So I'm also the co-owner of another company named Ocelli. We are an IoT hardware-ish kind of company. We connect time-worn problems with 21st century solutions. What we actually do is we focus on edge devices, nodes, sensors, and long-range, low-power. So we take sensors and we connect them to each other and to the world with long-range, low-power stuff. So before we get into the meat of my talk, we need to go over one thing, and that is we need to define IoT. IoT is it's a buzzword, and it means absolutely nothing. It is marketing 100% through and through. It's a really brand new word, but it's a really old idea. It's been around for decades. It used to be called M2M or machine to machine, and there's been 100 other names for it in the last 30 years. But the way that we're going to define it for my talk, and anytime you're talking to me, just in general, is connecting the physical world to the digital world. So you take something analog and you make it digital, essentially. And one of the things that's really funny about IoT nowadays is that everyone makes fun of the connected refrigerator and the connected toaster, and why does my toaster need to send a tweet? Well, the next time I'm gonna let you guys in on a little secret. Next time someone makes fun of that, you can just let them know about the first IoT device ever made. That was the Trojan Room coffee pot. This was at Cambridge in 1991. There was a group of engineers that had an office, and the coffee pot was in another room. And as all engineers, they're lazy. So when they got up and walked in the room and saw there was an empty coffee pot, they said, well, screw that, we're gonna fix this. I never want to do that again. So they set up a little camera next to the coffee pot. And then they wrote an HTTP protocol so that you could stream video over the internet. So they invented the first webcam so that they didn't have to walk into the next room over to find an empty coffee pot. So this was online for about 10 years. They took it offline in 2001. These are actual screenshots. Those are the best screenshots that you can get. That's how crappy the camera was. That's all the bigger the resolution is. So like I said, IoT is a really old thing. So what is it? Why do we care now? Let's talk about some practical things for IoT. Here's one that someone approached my company with last year, which was for Indianapolis to deploy salt when it's icy out in a fiscally and environmentally sound fashion. They need to know the temperature of 435 separate bridges inside Marion County. And right now, the way they do that is they actually they contract with a company who has a guy who has a pickup truck, and that guy gets in his pickup truck, he drives out to a bridge, he sticks his arm out the window with an IR thermometer, says, oh, it's 31 degrees, makes a phone call. And they do that 435 times. There's got to be a better way. The best part of that, actually, a little other side note there, is that company has exclusive rights to provide Marion County with weather data. So Marion County cannot get any other weather data from anyone else because these guys are able to drive a pickup truck to a bridge. Another one, and this is actually the reason that I got started in IoT in this kind of world in the first place, is in 2015 I discovered that Indianapolis had one of the highest pedestrian vehicle collision rates in the country. That's a car and a person making contact, hitting each other. And so Marion County spent a crap ton of money, we're talking millions, to do a study to figure out why this happened, and they figured out that that's because there's a sidewalk deficit. So there's a $70 million sidewalk deficit, to be exact. And to put $70 million into context for you, give it some, the entire transportation budget for all of Marion County is only $50 million. So what they did was they had to figure out where they should put new sidewalks, where they should repair old sidewalks. And so what they did was they tried to do counting. They tried to count pedestrians and figure out usage statistics and figure out where sidewalks should be so people can get from A to B. And there's 1,000 problems with that. But the main one, and the one that I took the biggest issue with, was that they bought one automated pedestrian counter for $200,000. It's permanent. It gets installed in one place. And I don't remember if $200,000 actually included the installation price or if that was just the device by itself. Either way, to get it installed takes 3 departments, one of which has to be cleared with Homeland Security because the sensor was, or the pedestrian counting device was actually installed near a bridge, and that has repercussions. So this pissed me off enough that I took 2 weeks off of work, which I'm a consultant, so that's just me telling people like Tyler that I don't care about them for 2 weeks. And what's up? And so I took 2 weeks off and took a Raspberry Pi, and I built this thing which counts people. So it's $75-ish, in about 2 weeks of my time, I got a thing that was good enough. And so those are practical examples. So why now? Why is IoT a thing? Why am I up here ranting about IoT at a Python meetup? Well, it's because I think the Raspberry Pi and the Arduino, essentially they brought down the price of hardware. They are letting people who have never actually been able to get into hardware before get into hardware because it's cheap. You can have a $35 computer and you have a server. You have anything you want. You can make a Raspberry Pi literally anything you want. Or you can spend like $100 and get an Arduino and a couple sensors. And now you have a little battery-powered thing that you can make do anything, right? So I think that these things have made hardware and the idea of the Internet of Things affordable and accessible to most people. And why does that matter? I think it's partially it levels this playing field. So, so anyone can actually do this, and anyone can own their own data, which has this like crazy socioeconomic thing. Magic, really, when someone can own their own data. So you can be a kid from Hawville, and you can go, why is it crazy with floods everywhere here and no one gives a crap? Well, it's because no one can prove that flooding happens. Well, you can make a little sensor, to find heat islands and why your grandma's house is 200 degrees hotter than your house. And you can do that, and you can own your own data. So there's a lot of things that make this really important. But the reason I think I got so excited about this idea was because this is what what I'd imagined the internet to be like when I was a kid. Like I would turn on a computer and everything would just be there. You didn't have to do anything. You just thought about something and then it just happened, So that's really why I got excited. So meanwhile, back to our problem. My company, Ocelli, we needed an IoT demo. So trying to go to people that will write checks to us, whether that's on spec or invest in us or to buy a product from us, if someone's going to give us money, they have to know what IoT is. And so we needed a demo to explain this to people because it's just been abused so much, the phrase. We also needed a project to work on together. So there's 3 of us in this company, and we haven't actually gotten the opportunity to work on all that much stuff together. A lot of projects end up being one of our expertise more than everybody else's, and so we needed something that would kind of let us all work together on something. And we work out of co-working spaces, the Speakeasy being one of them, and there's a lot of little annoying things, a lot of inefficiencies around here, so we thought we could fix some of them. And then also, the Speakeasy, in particular, is kind of a microcosm of a bigger community. There's people from all walks of life that come into the Speakeasy, that leave the Speakeasy, that work here, a lot of different levels of income, a lot of different backgrounds. There's 4 different Speakeasies, 5 different Speakeasies, so there's a lot of different locations. So really, it's like a synecdoche of a lot of city problems. And I just put the word synecdoche into a talk, so someone owes me, I don't know what, but So as an aside, what is the speakeasy? Well, it's a little bit easier here because we're actually inside the speakeasy, but it's a co-working space in Broad Ripple. It has 4 small conference rooms on the side back here, and then 1 larger conference room behind you. And lots of meetups are hosted here, and more importantly, and what makes it better than others, is it serves beer. So my company, our guys, we got this really big, lofty goal. We were going to make this amazing, amazing product. We're going to automate this whole speakeasy and just do these incredible things. We were going to make an online conference room reservation system. We were going to automate all these lights. So when there was no one here, we weren't wasting power, especially because all of the lights in here are actual like Edison bulbs that generate a lot of heat. We were going to have some glorious ways so you could get back inside when you went outside to the bathroom. And so you didn't have to carry your phone with you. We were going to do a meetup check-in. So when you walked in and you were RSVP'd for a meetup, you were already checked in so that, like Colleen doesn't have to do anything. So, I mean, they can finally take her off the payroll. Then we were going to have another thing that automatically turned off the blower. So we were going to have another thing that automatically turned off the blower when the speaker started talking, and then automatically turn the blower back on at the end of the meetup because we forget to do that sometimes, and then the speakeasy gets really mad because it gets really gross in here. And we were going to be able to turn off the keg so that Jeremy would quit drinking all the time. And then just to make things interesting, we were going to write all of this in 4 different languages. So we could compare battery life, of course, right? So we're going to write it in C, we're going to write it in Python, we're going to write it in Rust, we were going to write it in Node. And I know you guys are really excited to hear about that, but we didn't quite make it. So the first thing that happened there was the speakeasy, they actually signed on to the idea. Like they were like, oh, cool, let's make it happen. And it stopped being fun because we weren't breaking the rules anymore. The other thing was we now had a budget. And do you know how hard it is to actually justify the cost of stupid, over-engineered product? Like, that's literally what we set out to make, was like, how stupid of a crazy thing can we build? And then someone wants to give us money for it, and it's like, oh, now I feel bad. And then we had another thing that happened. Literally, it was life. Our electrical engineer, he decided to dabble in some genetic engineering, and he made a baby. Apparently he couldn't make it tonight, but what's up, Xander, which is the little one's name that he hates. It's funny, but it's now recorded, so that's real. So since we couldn't make that happen, we decided to focus on a slightly smaller problem. And that, just because it was a slightly smaller problem didn't mean we were going to do any less crazy and stupid to it, and so that's what we stuck with. We purposely made this like really over-engineered so that we could expand it out to do anything we wanted later on. And so that problem is the conference rooms back here. So currently, the way that you make a reservation for a conference room is you walk into the speakeasy, physically walk into this location, you walk over to the conference room, you look at a whiteboard, and you say, okay, oh, it's free now, and you write your name on a whiteboard, and now it's reserved for you. So if you guys want to really screw with someone, go back there and erase one of them right now. It'll be hilarious tomorrow, I promise you. So there's a couple of problems. So there's plenty of problems with that, obviously, but like one of them is you can't really tell when a conference room is being used currently. So like you try to look through the window or the door, you can kind of see, but you really can't. So what you do is you have to like kind of crack it open a little bit and go, oh, sorry, oh, why aren't you wearing pants? You know, like it's a little bit weird, but it's really obnoxious. So this is what we built. We built an online calendaring system that would put a little display outside the door there so you could see if it was currently occupied or when it was reserved. And then we have a little traffic light that tells you, is the room currently in use or will it be in use soon? And the last little thing there is an IR sensor, or a PIR sensor to tell you, occupancy sensor, we'll just go with that. So I'm going to go through the different parts of this and how we built it. So first thing is this calendar. This is not really that exciting to a Python meetup. It is almost entirely JavaScript. Actually, the front end for it is entirely JavaScript. But the back end for it is where things get a little bit interesting. It was an excuse to write an entirely serverless application, so we did. So this is using AWS API Gateway, AWS Lambda in Python, and then AWS DynamoDB. And here's some code. Now, if anyone's really good at counting, you can count how many lines of code that is. But it's 13 if you're not good at counting. And you'll notice that 3 of these lines are logging. So they're completely unnecessary if you don't want to ever debug. So if you take out those 3 lines, it actually comes down to be like 8 lines of code, and that 8 lines includes 3 lines of white space because we all follow PEP 8 standards, right? So this is really 5 lines of code, and you're able to make an entire, basically an entire backend for a service. That's how easy Lambda is. This is the same thing. This is the same thing for adding a new event to the calendar. So this is the post. It's exactly the same thing, except for you're sending some JSON instead of asking for JSON. Again, it's like 5 lines of actual code. So just a second ago, I told you that this was a serverless application, and I lied a little bit. But in my defense, the server is actually a Raspberry Pi. And so I don't count it for much. It has a cron job that's written in Python. And that cron job, it pulls events from API Gateway, Lambda, DynamoDB, and it publishes those to an MQTT message bus to AWS IoT of all of the events that are happening soon and will be happening and that are happening right now. And don't worry if you don't know what any of those things were I just said. I get to those in a second. So it sends those events to the display so the display can be seen. And this next slide I'm really excited about because all of you are going to know exactly what it does, and I don't have to explain anything because of Calvin's fantastic PBJ session. So I actually didn't do this on purpose. This was legitimately the code because I'm really lazy and like list comprehensions a lot. But this is actually everything. This is how it sorts everything and figures out what actually is happening now and what will be happening soon. And this will make a little bit more sense here in a second. So again, this is, you can see that I actually have I have a class and then a couple of functions there, but I promise you the get reservations is just a requests request. So it's probably like another 2 lines. The reservations class, I guarantee is probably 15 lines total. So this is less than 25 lines of code, and you're able to do a lot with it. So this is actually, you can kind of see, this is kind of what the server / display thing looks like. It's a Raspberry Pi, and I have it over here. You guys can see it in a minute. And then the traffic light there in the background. So this is the code that runs the display. So the display was supposed to be a little e-paper display to go up on the wall because all of this is supposed to be battery powered. Or actually is battery powered, but the e-paper displays are really expensive, so we went with a normal Pi display. And the way that works is there is a service on there that I'll get to in a second, and whenever something comes in there and it gets told to display it, what it does is it writes an index.html file, and then I have a browser, the default browser on the Raspbian that just sits open on this page. And what's interesting about, I think it's Midori is the default browser, is that for some reason it auto-refreshes anytime the HTML changes. So I didn't have to write anything to make the display server work. Like it just worked anytime I changed this HTML file. So I think anyone can make this happen. So as another aside, I've mentioned a couple pieces of technology here that maybe not everyone knows. MQTT is a lightweight messaging protocol. It's a pub sub. So what that is means that like you have a topic is what they're called, but it's basically a URL where you send data to it. And then so you can publish to that URL, and then that same topic, someone can subscribe to it. So it's basically like RSS, if any of you are old enough to know what that is. But it's really lightweight. It's been around for probably a couple of decades, and it works really well. The other piece of information, or the other piece of technology here that we used is LoRa. LoRa is a long-range, L-O, long-range, R-A, long-range, low-power wireless protocol. And there was absolutely no reason to use it for this project, except for that's what my company kind of specializes in, is long-range low power, and LoRa is one of the ones that we use and we like a lot. So while these conference rooms are within like half of, not even a foot of each other, they could actually be, let's say a couple miles away from each other, and it would still work just as well. So when I say long range, I'm not thinking meters, I'm thinking kilometers. When I say low power, it's not days of battery, it's years of battery. So we could have a conference room like in Lawrence or something like that, and it would still pretty much work the same as it does right now and run off of a battery for, say, a year. There's absolutely no reason that we need that, but like I said, we were bored. So this is the motion detector, the occupancy sensor. All this is a normal passive infrared PIR sensor. Here's where things get a little bit interesting, is that it's actually running Python. So this little sensor is running Python. It uses LoRa to send an MQTT message of the current room status. So anytime there is movement in the room, it says, cool, I'm occupied, and it sends a little message. This is almost the entirety of the code. I put all the meat up here. There's a little bit of code that abstracts some stuff away that I didn't put up here, but that's really just importing some stuff, and I made a class so that I didn't have to remember a couple of things. But so all this does is it says, hey, something happened, and just because if there's someone actually in the room and they're moving a lot, you don't want to keep sending a lot of messages, so it just counts till, I guess, 5 minutes, and says if something hasn't happened or something has happened in 5 minutes and that's different than what it was 5 minutes ago, then it sends a new message. And this is all running MicroPython. So MicroPython is a smaller implementation of Python, because Python is a specification to make a language. Python is not the actual implementation. You guys are used to using CPython for most everything, but there's also Jython, Cython, there's PyPy. There's a bunch of them. There was a project at PyCon this year that got announced and then abandoned immediately, like 20 minutes later, called KrustyPy, which was, Python written in Rust. I don't know who actually started that project. So MicroPython. That's what it's Python built for microcontrollers. And ocelli, we've done a few projects with MicroPython in the past, and I previously mentioned that we had planned on doing this. This project wasn't planned to be done entirely in Python, and there's a very good reason for that. And that's that, so those of you in the room that know me might know that I have a penchant for hyperbole. This, I assure you, is not. But at the time of this writing, it's probably a little bit less than this now, but at the time of this writing, I would say roughly 10 to 15% of all of the knowledge of MicroPython was actually in this room. That is how bad the documentation was for it and how much stuff had to be figured out by you every time you used it. It's probably good for prototyping, maybe good for prototyping, but it's got a long ways to go before you should be putting it in to production. So for an example, we do a lot of stuff with the ESP8266 microcontroller Wi-Fi board, and we couldn't use that for this project. We actually had to buy a specialty board that was built specifically for MicroPython, because the ESP8266 only has one UART, and MicroPython requires a UART dedicated for the REPL, and you can't disable the REPL. None of that means anything to you if you don't. It doesn't matter if you don't know what that means. It's just me wanting to get on record that I hate MicroPython. So this is where things might be slightly out of date for this talk. I'll say that I haven't touched MicroPython in quite a while. I do know at PyCon I talked to a couple of the guys from Adafruit. And they were also frustrated with MicroPython the same way I was, and so they had forked MicroPython. The fork was called CircuitPython. I hope they've fixed everything that was wrong with MicroPython in CircuitPython, but I can't be 100% sure of that because I haven't had time to play with it. But you should check out CircuitPython, and you should give MicroPython an honest try before you write it off and go find a better language for writing embedded systems. And don't just take my word for it. So, traffic light. So you can see this is just a breakout board for the Raspberry Pi. It's unnecessary. It's only there just because it makes it easier to put a breadboard on here. red, yellow, green, traffic light. Red is the room is currently occupied or the room is reserved. Yellow means the room will be used in the next 15 minutes, but it's otherwise available. And green means the room is empty and it is not reserved. So this is a portion of the code that runs, and this is MicroPython. This is actually running on a microcontroller. It looks a lot like Python, right? There's a class here, traffic light, and that was just because I kept forgetting what the arguments were for LEDs. And so there's another, I want to say another 20 lines or so that's not included here on this slide. But that's pretty much how easy it is to get an LED to turn on and off on a little microcontroller. So to build the MVP, we spent, like I said, we had months to work on this thing. We built it all in about 2 weeks because we're really, really bad at doing things. So this is what, yeah, I'm glad somebody laughed. So this is, again, the traffic light with the Raspberry Pi. This is one of the gateways. This is actually the gateway. This allows things to communicate with LoRa. So this is kind of like your router at home for your Wi-Fi network, except for this can connect to about 10,000 devices, and those devices can be about 5 miles away is average with good line of sight. However, I will say that the record for the longest LoRa packet ever sent was broken Thursday of last week. It's 725 kilometers, which was from Amsterdam to someplace on the opposite side of Poland or something like that. It was just insane. Now, mind you, that was in a helium balloon. But it happened. So again, some stuff here. It's the same thing. This is the stuff that goes inside of a gateway is there with the big antenna. This is a LoRa node that we use to test things. It just tells you the temperature of whatever the keg is right now. More. This is actually the LoRa chip. Some there. So when I gave this talk the first time, I had to give the talk the next day. We weren't done with this thing yet. And my brother was helping me out with the soldering because at the time I was really, really bad at soldering. And I'm still not much better, but I think I might have been able to do this. But so he stayed up after I went to bed at like 2 or 3 in the morning, and he soldered some stuff together to get this thing to work. And what's funny is I didn't know until today, actually, that stuff didn't work at all when we showed up the next day. Like, he completely lied to me that everything got done the night before. So, like, I actually didn't know until today. I said something about, I said how I was going to include the thing about the cable breaking, because we have this little box here. This is actually the motion occupancy sensor, right? And it's in this nice little case, and it's screwed shut, and it looks like crap on the inside, but it looks really nice on the outside, right? And it's battery powered, and it connects to Wi-Fi. Or does it connect? I don't remember. This is battery powered. It's not that it connects to Wi-Fi. It's battery powered, and we forgot to unplug the battery before we sealed it up. And of course, we get there and realize I'm not speaking till the afternoon, and like we don't want to take any chances that something is running in the background that we haven't thought about, and so the battery's going to die. And so Aaron goes to unscrew this thing, and I didn't realize that he'd actually had to make a homemade cable because he didn't have the right connector. So he'd like soldered some like ridiculous cable, which of course broke the second we opened this thing. And so, before my talk, he actually had to run to Fry's to buy the right cable to make this thing work. And so I told him I was going to fit that anecdote in this talk, and he goes, well, what's funny about that is that wasn't the only thing that was broken at the time. And apparently, like, all of the, so we're using a lot of cloud services to make this work, and one of the main cloud services we were using went down, and it just happened to come back up during, like, while I was complaining, like, to him, like, before. So I didn't know until today. So when I gave this talk the first time, what I actually ended up saying here on this slide was, I pulled it out and I started showing it off, and I said, we'd finish this within the last 12 hours. Well, it turned out we'd actually finished it within the last 12 minutes. And so I was really proud to tell that story here tonight, and then then we got here tonight to find out that the speakeasy had actually decided, so like I said, we're doing everything that we can to not have to touch Wi-Fi. We're doing all these other protocols, but there is a tiny bit of our application because we didn't actually do this exactly how we wanted to do it that has to touch Wi-Fi. Well, the Speakeasy decided to buy some real networking equipment as opposed to the homemade, or your normal stuff you have at your house that they've been using for years. And they installed it this week. And it doesn't let devices talk to each other over the network. And so we actually, for my talk here, we finished it. I've been talking for 31 minutes, so we probably finished this about 41 minutes ago, 42 minutes ago. So that's pretty good. So I'm going to wait here in a second, and I will pull this stuff out so you guys can look at the actual hardware. But it's kind of delicate, so I don't want to do that without the lights on, or without, I'll take over a table so you guys can actually come around and look at it. But so again, I'm Cameron, and you can find all my contact info at pinkcatbeard.com. The company that I just co-founded is named Ocelli. That's our URL. And you can find slides and some of our code at our GitLab. Note that that's GitLab, as in the better version of GitHub, because it's free and open source. It's GitLab. So yeah, thank you.
All right, if anybody's got questions for Cameron, please come over to the mic, and that way we can get them recorded. Anybody got questions? Come on, there's got to be some questions. Python, MicroPython, IoT. So okay, I've got a question.
Yeah.
What is the current status of MicroPython? Have you been keeping track of the project?
Has
it moved?
I really haven't been following it since I tried to help out on their sprints at PyCon, and they weren't in the room, and so I went over and worked on Beware instead. And so I really don't know what their current status is.
And did you get a coin?
No.
You didn't get the Beware coin?
No, I thought I was actually eligible for a yak herder coin.
Yak shaver?
No, the yak herder.
Oh, okay.
Because you herd yaks to be shaved, I believe is how it works. And I was actually, I think, technically eligible, but the one wasn't witnessed by someone that could actually vouch for me, so I didn't get my coin. But that will happen at the next Python event.
All right, has anyone else got any questions for Cameron? Oh, Gene, come up here.
So Cameron, can you tell us a little bit more about the capability of LoRa? What's the bandwidth available?
So the bandwidth is really crappy. It's a text message about every 10 minutes. But that's because that's what IoT needs. If you're doing anything where you need real bandwidth, if you're trying to, if anything needs real time, you shouldn't be calling that IoT. You should be calling that something else, because IoT is not about life-saving things are not IoT. So LoRa can send about a text message, like I said, about every 10 minutes, and the 10-minute thing is only if you're using free networks. If you want to roll out your own LoRa network, which is you can roll out your own LoRa network for probably between $10,000 and $20,000. You can have one that will cover. You could cover most of Broad Ripple for probably maybe $25,000 or $30,000. So it's fairly inexpensive when it comes to long-range and networking. But like I said, it's really small packets and it's really slow. That's because you're doing this for sensors and to just know things are alive. One thing that LoRa lacks that I wish it was doing a little bit better at is location services. It's actually kind of hard to figure out exactly where something is. So if you're trying to track, if you wanted to put a sensor on a bicycle to know it was stolen, you're not going to be able to track it that accurately. You can get a good ballpark, but it's not to a block or a foot rate. You're not going to find it.
Okay. What frequency band is?
It's ISM 900. So it's in ISM band. So it's the same public open network that a lot of things are in. So what LoRa is actually based on an old protocol from the 70s when they tried to network all of the Hawaiian Islands together, called the Aloha protocol. Huh? Because it's Hawaii. Get it? Anybody? And so it uses this frequency spread spectrum frequency hopping thing. And so the fact that it's in a really saturated network doesn't matter for LoRa. it's really good at finding where it needs to go, because LoRa actually kind of thrives better when it's being bounced around. So it kind of does things really good when it's crowded. Like it's better than a lot of things as far as that goes.
Thanks.
See, this isn't so much on the technology, but when you built the sensor as an alternative to the $200,000, person walking detector, that's really impressive. Did you have any luck getting like the city to adopt it?
Well, so when I first did it, I did it to prove a point, and I went around and I actually tried. This was 2 years ago when I did that, I think. And so at that time, 2 years ago when I first started that project, I spent 3 days a week probably going to different government events in Marion County to try to find and talk to the right people and get everything. I, at one point, probably knew like a giant percentage of our local government because I was trying to get things made. But I realized a couple weeks into this that my thing was actually more expensive than their thing that they'd spent $200,000 on. So the $75 piece of hardware was more expensive than a $200,000 piece of hardware, because mine came with the promise that you could deploy a whole bunch of these for really cheap. But the problem was I had no way to make them communicate together. So you'd actually have to pay a guy to, walk down the Monon, which you'd need about 400 of these things on the Monon to make any, real, or 400 of them on the trails here to do just the greenways. And someone actually have to pull SD cards out once a week and swap them, so you can get the information off, because I couldn't network them, because you can't make Wi-Fi work in that kind of situation. So that's actually how I stumbled upon LoRa, was then I could do all the processing on a Pi and then just send ones and zeros that counts off. So no, I never actually got much traction with it, especially because when you have to deal with the government, it's horrible. Don't ever do it. And I'll say, like, so if I want to do something on the greenways, I have to talk to, again, like that's 3 different departments. If you're doing it on a sidewalk, there's actually private businesses that actually own part of the sidewalk, so you have to get a lot of things there. And then I'm doing stuff with computer vision, which gets a little bit sketchy because people get weirded out by the fact that you're taking pictures of everyone all the time. And so I didn't get very far with it. I didn't push it too hard either. I proved the point I wanted to, and I can get meetings with anyone I want, so I don't care anymore. I got what I needed.
Nice. Okay, thanks.
Thanks, Cameron.
No.
I really enjoyed that.
We don't listen to people from
talk.
Detroit.
Yeah, you have to let me tune into my my Detroit accent here. My question's in a similar vein. It's kind of non-technical, but I just wondered what, it's good kind of demonstrators you're talking about. So what's the what have been the learning points of greatest magnitude and greatest impact in those exercises?
Well, I think a lot of it is we've definitely learned not to underestimate how complicated a project can be. Like, it doesn't matter how easy it seems like. There's always going to be someone that decides to replace the networking equipment at the speakeasy 10 minutes before you show up. So that's been a big lesson, is that. But I think one of the hardest things for us, and the reason why we have to do projects like this all the time, is because it's really hard to get people to understand what it is you're talking about. So you have to come up with these kind of silly examples just to get someone to pay attention long enough to understand what it is. So that's been a big lesson for us, is just how to get people to actually go, how to get you kind of want to slap someone and be like, no, what he said IoT is stupid. That's stupid. This is what it actually is. And you have to come up with a really polite way to do that, which is making some pedestrian counter that is ludicrous, I can't think of a lot. I mean, we've had a lot of lessons, and we've kind of talked about some of them before. I'll just say one that's relevant to you. Maps are hard. So.
All right, let's give another round of applause for Cameron. Thank you very much.